All right, welcome back. Today's lesson is about something called common logarithms. That's section 10.4. Obviously, because it's called common log, it's one of those logs we use a lot. And the common log is log base 10. But many times they don't actually write the 10. Now, I'm going to keep writing it because when we're doing algebra, people kind of need that little assistance to kind of remind themselves how to do the problems. But log base 10 and the log without the 10 down here is the same thing. Let's take a look at what that looks like on the calculator. All right, down on the calculator next to the 7 button, there's a log button. You notice there's no 10 there, but right above it is 10 to the x. A little hard to see that here in this light. But this is the log base 10. And then right below that happens to be another log button, which we'll deal with in a couple days. It's called the natural log. They abbreviate that LN here, natural log. We'll be dealing with that one. But the bases, they function the same way in terms of how you solve the problems. It's just that the base is a little different. Now let's do a problem here. All right, we're going to take log base 10 of 6 and see what we end up with here. So I'm going to hit log. Notice it opens up parentheses for me. The base 10 is not showing, and it won't. And then a 6, I could close the parentheses, but because I'm done here, I don't have to finish the parentheses off here. So I've got an enter, and I get this number, 0.7781. Actually, we're going to round that to 0.7782. This number happens to be, we're going to run all of round all of our logs to 4 decimal places. Make sure you're rounding to 4 decimal places. All right, let's do this one, log base 10 of 50. Now, remember that what we're doing here with logs is we're asking a question. It's an exponent question. We're saying, what is the exponent on 10 that will give me 50? Well, 10 to the first power is 10, and 10 to the second power is 100. So I would expect that log base 10 of 50 is somewhere between 1 and 2, probably close to the middle. Let's go ahead and take that. Log base 10, again, they're not showing the 10, of 50 equals 1.6989, or that would round to approximately 1.6990. Don't forget to put all the places in there. 6990. Now it allows us to put 7 rounds the 9 up to a 10, which rounds the 8 up. But you got to put the 0 there as well to show that you've actually rounded to 4 decimal places. All right. Now you notice there was no other log buttons on there with different bases. So how do you take the log of something with a different base? Let's say log base 6 of 8. Okay? Log base 6 of 8. Well, we don't have a button for log base 10, but let's see that there actually is a conversion formula. I'm going to show you how that formula is derived. Let's go ahead and set this equal to n so that we can work the problem. Now remember, we're going to use the same properties we did way at the beginning here. We're going to drag down the result, throw the exponent to the other side, or base to the other side, and apply the exponent. So 8 equals 6 to the n. Well, there's no way I can get the common base here and do it the way we did before. So we're going to have to use the law of logarithms and solving logarithms. We're going to take the log base 10, I'm writing the 10 here, of both sides. Log base 10 of both sides. And then using the properties of logarithms, the power of power properties, we're going to move that around to the front and multiply. So log base 10 of 8 equals n times log base 10 of 6. Now I'm doing this problem for the first time here, but you don't need to keep doing this because there's going to be a rule that we can follow. Now to get n alone, I'm going to have to divide both sides by this here, this log base 10 of 6. Log base 10 of 6. And so now n is alone, and what's it equal to? Well, n is alone, and it is equal to, I'm not going to write the 10s this time, log base 10 of 8 over log base 10 of 6. Now, let's compare that to our original problem. Look up here. Notice to convert anything with a different base other than 10, we're going to take log base 10 of the top number and divide it by log base 10 of the bottom number. So in short, all we have to do is take log base 10 of the top number and divide it by log base 10 of the bottom number. This is called the logarithm conversion, logarithmic conversion, the base conversion formula, the change of base formula. And that particular formula can be generalized in a certain way. Let's take a look at that. All right, so here's the generalized version of that same formula. We've used letters here instead of numbers. Log base a of n is equal to log base 10 of n over log base 10 of a. Notice the top number goes on the top and the bottom on the bottom. In fact, these 10s don't even have to be 10s. They could be log base b of n over log base b of a. Well, that's the same as log base b log base a of n. So again, we put the n on the top and the a on the bottom. The bases just have to be the same here, and we can generalize this formula. But this is the one we're going to be using most of the time. So hang on to that. It'll be used during the assignment today. All right, that's pretty much the new material for today, but we do have a couple of special problems that are going to involve a little bit of extra finesse. Let's take a look at problem number 8 in your book. All right, let's do this one. Since I can't smell a base here that can be used in both of them, I'm going to take the log of both sides. And so we can use any base we want to, but I'm going to use log base 10 of 4 to the 5n and log base 10 of 30. Notice I'm undoing this exponent. My goal is to get this exponent to come down and undo it, get it down off of its perch up there and come down. And what undoes an exponent but a logarithm? So these logs are undoing this exponentiation here. So we're taking the log base 10 of 4 to the 5n. Now, notice that the power of powers rule is I can bring this around to the front and multiply it. I'll put a dot here. Now, my goal is now to get n alone. Well, the good news is it's down on the line now, which is what I wanted to do. N has been multiplied by log base 10 of 4 and also 5. So I'm going to divide both sides here by 5 and by the log base 10 of 4. Log base 5 and the log base 10 of 4. Both sides have been divided by the same thing. Okay? And what should end up happening here is log base 10 of 4 cancels, and these 5s will cancel, and we're left with n is greater than this guy right here. Also, if we use our calculator, here's how we're going to do that. We got to make sure that we put all of this in parentheses, and we've got to put all of this in parentheses when we go to divide. If we don't, we'll end up, and your calculator is also going to throw you up as a parentheses here. You're going to have to close that one as well. So there's going to be lots of parentheses as we do this problem. Let's see what the calculator looks like. All right, let's take a look at the calculator here. We're going to enter the thing on the right side over here. All of this is gone on the left. We're going to start with a parentheses and hit log base 10, the 10's not showing, of 30. Notice it opened a parentheses for my 30 there. Close that and close again to close the numerator. And we're going to divide by open parentheses 5 times, and I don't need to hit times here, but I will, log base 10 of 4, close parentheses, and I end up with an answer of 0.4907. And there it is. Now, this process is pretty much the same. There's a couple of problems that have a little bit more involved, which is not quite intuitive, and we'll take a look at those here in a minute. Let's look at another. All right, here's one. Notice x is up in the exponent. It's also squared, so we may end up with two answers here. Now I don't smell a base that can be used in common here. So what we're going to do is take the log of both sides. And I'm going to use log base 10. By the way, I'm still writing it, although I don't have to. Log base 10 of both sides. All right, now as we know, what do logs do? Well, they undo this exponentiation, and that causes this to drive around to the front. Since we're requesting powering, we're going to turn it around to the front and multiply. So it's out on the front now, being multiplied. Okay. Now, if I want to get x alone, well, what's been done to x? It's been squared and then multiplied times this log. So the first thing we're going to do is divide both sides by log base 10 of 11. Log base 10 of 11. And of course, these are going to go out, and we're left with x squared equals all of this. Okay? So rather than write it over again, I'm going to write the word this here. Now, to get x, I'm going to need to take the square root of both sides. And of course, by taking the square root of both sides, I need plus or minus. Remember, when you're taking the square root of both sides. So now x is equal to plus or minus this particular log here. By the way, using the word this kind of shortens my work a little bit. It may be unconventional, but it seems to work for me. Let's take a look at this on the calculator. All right, I want you to notice that I'm not going to round in the middle of the problem. If I would have found the log of this and rounded it and then took the square root, my answer would not be as accurate. So that's why I went all the way to the end, and I'm solving for x now. So here we go. I'm going to take the square root of, and I'm going to open parentheses here, log base 10 of 25.4. Close those parentheses, and let's get out from underneath the parentheses here. Since the radical acts like a parentheses, I didn't need that on the top there. And divide by, oops, I'm sorry, I got to take the square root of the whole thing, so let's back up again here. Still underneath, divided by, parentheses, log base 10 of 11. Now I'm going to get out from underneath the radical. So let's look at it again. Log base 10 of 25.4 divided by log base 10 of 11. I'm going to have to close that parentheses again here. Okay, I closed the numerator, and I also closed the denominator. Actually, I've got an error over here I got to go back and fix. I don't need this parentheses right here. That's going to confuse it. Okay, take the numerator and divide by the denominator. Okay, and our answer ends up being 1.1614. So this is 1.1614. Actually, 1.1615 if we round this properly. Now that's the positive answer, but don't forget that we needed to have plus or minus. So I know that the answer is going to be just the negative of this, but if we needed to, we could go second entry and go out here to the front and change that to a minus sign. I'm going to go up here in the front, and by hitting second delete right here, second delete, I'm going to insert a negative sign in here, and now take the square root of that, and I get the same answer, but it's negative 1.1615. So there are two answers when you have an x squared in the problem. All right. All right, now let's take a look at a problem here that is a bit new, and it's not intuitive to figure this one out. And the reason why it's a little unusual is that there's a variable on both sides. Let's take a look at it. Number 11, 7 raised to the t minus 2 equals 5 to the t. The fact that there's a variable on both sides is going to make it a little challenging, but we can do this. We're going to have to use some tools in our toolkit. Again, it's not intuitive, so I'm going to show this to you. But in order to solve for a variable, I have to get that variable alone. I have to be one variable. So I'm going to have to find a way of getting these two together. Well, once again, we're going to take the log base 10 of both sides. So let's go log base 10 of 7 to the t minus 2 and log base 10 of 5 to the t. Now, as before, these exponents will come down. if we drive them around to the front and multiply. So I've got t minus 2, and you'll notice I'm putting it in parentheses because the whole thing is multiplied here, log base 10 of 7. And let's drive that one around to the front, and that's t times log base 10 of 5. Now, we still haven't got the variables together, and that's the little finaglery that we're going to have to do right now. It's not intuitive, but we're going to need to distribute this in here. This log base 10 of 7 is going to have to get distributed into both of these items. So here we go, t times log base 10 of 7 minus 2 times log base 10 of 7, and then we'll bring the other side down. Now, in order for us to get these t's together, we're going to move this whole thing that way by subtracting, and we're going to move this whole thing that way by adding. And the goal is to get the t's together on the same side of the equal sign. So I want this one over here. So let's copy this down, t log base 10 of 7. When I subtract this from both sides, I get negative t log base 10 of 5. And then if I add this to both sides, I get 2 log base 10 of 7. Now, I did that pretty quickly by just moving this to the other side and changing the sign. Moving this one to the other side and changing the sign. Now, the reason we did that is now we have t in both of the terms here. And we can use a well-known tool called factoring. We're going to pull a t out of each of those. And now the variable is in one place. I'm going to take a t out of both terms. Log base 10 of 7 minus log base 10 of 5. And then copy this part down. Okay? Now, let's move down the page just a little bit here. If I divide both sides by this guy right here, t will be alone. So I'm going to put that right here. I'm going to divide both sides by log base 10 of 7 minus log base 10 of 5. Same thing over here. Log base 10 of 7 minus log base 10 of 5. I'm going to divide both sides by that amount. Now when I do that, I end up getting these two to cancel. These are identical, so they should cancel. And t is now left alone. If we stuck this in the calculator, let's see what we get. All right, I went ahead and inserted this in here on my own. Let's enlarge this a little bit so you can see it a little bit better. Notice I had to start with a parentheses up front here. Start with a parentheses and close that numerator with parentheses. Start the denominator with parentheses and close it. Don't forget, every parentheses has got to have a mate. So the 7's got 2, 1 around each of it. 5's got 2, 1 around each of it. The numerator has 1 around it, and the denominator as well. And we end up with the answer 11.5665. So let's go back down here and take a look and write that answer in here. It's 11.5665. Now that's a long way to go, but the process is pretty much the same each time. Go ahead and move the exponents around to the front like usual. You'll have to distribute, move some terms, and then factor. So you end up, expanding and factoring in the same problem, just so you can get everything on the same side. That's cool. Let's look at another one. All right, let's take a look at this one. If you recall, whenever we have inequalities, there's a couple of special things at play. And one of those things that's at play is the fact that if I happen to divide or multiply both sides by something that's negative, I have to turn this sign around, and that's what's going to happen on this problem. So we're going to start the same way. Notice there's variables on both sides here, so we're going to have to do the same we did in the last problem. So let's take the log base 10 of both sides. Okay, exponent up here, and because we're taking the log of both sides, the powers of powers, I can drag those around to the front and multiply. So drag this one around to the front, multiply. Drag this one around to the front and multiply. And notice I'm putting this in parentheses. It has to be grouped together. All right. Now just move those exponents around to the front and multiply. Again, powers of powers. The property says we will multiply the logs together. So I've got an n here and an n here, and in order for me to get them together, I'm going to have to break this apart by distributing. So let's distribute those items on the right side. I'll get distributing the log base 10 of 52 in here. I'm not going to write the 10 right now just because it's not needed and it's a little extra less to write. So this is 4n log base 10 of 52 plus 3 times log base 10 of 52. All right, now I've got these two separated, so I can actually move this one to the left, and I'm doing so that the ends are on the same side of the inequality. So I'm going to bring it over here, and when I do, it becomes negative. It's easy with all the writing that we have to do to miss a number or miss some details. So I'm talking here. It's a little hard when I'm distracted to make sure I don't mess up a little bit. But got to be careful as you're copying things over that you don't miss anything. Now, looking over here, n is on the same side, and I can take out an n. I don't need to take the 2 and the 4 out, but I'm just going to take out an n. Let's pull an n out. That leaves us with 2 log base 10 of 8. Minus 4 log base 10 of 52, and that's greater than 3 log 52. All right, now n is almost alone. I just have to divide both sides by this, and I'm going to use an abbreviation and an arrow. I'm going to divide both sides by this thing. Divide by this, divide by that. That way I don't have to write it again. It's my little notation. Now there's something important here, and that is this thing that I'm going to divide by, if in fact it is negative, then I'm going to have to turn this sign around. So I want to find out if this thing is negative here, so I'm going to use my calculator to do that. All right, we're going to enter this item right here and see if it's negative. Now, I'm not worried about it. I can store it in my calculator and look at it in a minute, but I want to know if it's negative. So we're going to enter it in there. Parentheses, log base 10 of 8, close the 8, minus, well, I left out something, didn't I? That's 2 log base 10 of 8. By the way, notice that in the calculator it looks like 21. It looks like 21 up there, but that's 2 times log. The L and the 1 look the same in this calculator. 2 times log base 8 minus 4 times log base 52. Close the 52, close the numerator, and see what we get. In fact, we did get a negative number here. Negative 5.0578. Now, I don't need to write that number down. In fact, I don't want to, because if I round it off now, my answer will be affected. But what we are going to do is we're going to take that number and we're going to use it in a second. So let's take a look at the other number we're dividing by. It's over here. Parentheses, 3 log base. We're looking at this number right here. 3 log base 10 of 52. Close the parentheses, close the numerator. And we're going to divide it by that number we just divided by. I don't have to enter it again. I'm going to use my answer key. That's second, and way down at the bottom, you'll see answer, and it pulls up that old answer. And we hit enter, and we end up with this number here. Negative 1.0178. There it is, negative 1.0178. Now, I just divided by a negative, so that means I have to turn this sign around. So our answer is actually the inequality has been turned around now, and n is less than. When you divide by these logs, you're not sure if they're negative or not unless you put them in your calculator. So go ahead and put that one in the calculator first, see if it's negative, and then you can enter the other one and use the answer feature. Dividing by this first and then that, you won't know if that was a negative number or not when you stuck it in there. So this property, or this feature of being able to use the answer key is a powerful tool. Let's look at another one. All right, let's take a look at this one here. Again, there's a variable on both sides. Be careful as you're writing these problems out that those exponents stay high like this. If they don't and you let it creep down, you might begin to think it's 3n minus 2. But it's 3 to the n minus 2. Now, as I look at this problem initially, I realize that I can write the square root as the half power. So I'm going to rewrite that. This is 3 to the n minus 2 raised to the 1/2 power. Remember, square roots are the half power. And of course, powers of powers means I can actually multiply the powers. Well, I'm going to have to distribute here. This is 3 to the 1/2 of n. Let's just call it 0.5n minus 1/2 of a negative 2 is a negative 1. Okay? 3 to the 0.5n, half, I just write a little less there. Okay? Now, we're going to go ahead and take the log of both sides. That's a little way of simplifying the problem before we start. That's a decimal point right there. All right, let's take log base 10 of both sides. Remember, those exponents got to look nice and high there so they don't get confused. All right, since we're requesting a log here, we can drive that, use the power of the product and drive that around to the front. This is now 2 to the n, I'm sorry, this is just n, times log base 10 of 2. Drive that around to the front, 5n minus 1, put a parentheses around it, log base 10 of 3. Remember, the exponent just drove around to the front. Now, once again, we've got variables on both sides, so I'm going to have to distribute this into both of these. And we get 5n log base 10 of 3 minus 1. I'm not going to need, I don't need to write the 1 there, minus log base 10 of 3. Okay? 5n minus 1, 5n minus 1 both got multiplied in. Once again, the L and the 1 look so similar, it's hard to see sometimes the difference. All right, we need the n's to get together, so we're going to move this to the left. And when I do, it becomes the opposite sign. So we've got n log base 10 of 2 minus 5n times log base 10 of 3 equals negative log base 10 of 3. All right, so I need to go ahead and pull an n out of both of these. Take an n out of this, I get log base 10 of 2. I'm not going to write the 10s here. Minus 5 log base 10 of 3 equals a negative log base 10 of 3. It's like we were too low there a little bit. Okay. All right. So we're going to move this up to the top so we have a little bit more room. All right. Now the double variable now is a single, and we're going to divide both sides by this thing. Now I'm just going to write the word this. Dividing both sides by this. Now you'll notice I don't have to check to see if that's negative or not now, because this is not an inequality. I don't have to worry about whether the sign's turned around or not. So I'm just going to grab my calculator and divide this out. All right, so we're going to take and divide, use a parentheses, negative. Make sure you use the negative button here and not the subtraction button. Log base 10 of 3, close the numerator, divide by, open the denominator, log base 10 of 2, close the 2, minus 0.5 times, I don't have to hit the times button here, log base 10 of 3, close the 3, close the denominator, and I end up with 0.2289. 0.2289. This is problem number 43.2289. I just realized that I had dropped that 0.5 here. It got lost in the process. Let's try that again. So here we go. Clear. Parentheses, negative, log base 10 of 3, close the 3, close the numerator, divided by, parentheses, log base 10 of 2, close the 2, minus 0.5, log base 10 of 3, close the 3, close the denominator. And the answer is the answer I was expecting here. Negative 7.6377. Negative 7.6377. Decimal point makes all the difference in the world, and I lost that in the process. So there you go. The process is the same on all of these. Just make sure you're using a lot of parentheses with your calculator. All right, let's take a look at a word problem here. As mentioned before, there are several different applications of the logarithmic scale. One of them is pH. Here's a formula for calculating the pH level of a substance, and that substance, if you know the hydrogen ion concentration. And so this formula happens to come from page 546 in your book. I'm going to do problem 25 here, and 25 is talking about lemon juice and the calculation of the hydrogen ion concentration is 7.9 times 10 to the negative 3. Okay? Well, we can go ahead and plug that in our calculator, and we can do it a couple different ways, but let's plug it in. The pH is negative log base 10 of 7.9 times 10 to the negative 3. And let's just go ahead and stick that in our calculator. Okay, so I've made that calculation here. I took a negative, make sure you use the negative button, not the subtraction button. The negative log base 10, and of course the 10 doesn't show here. 7.9 times 10 to the negative 3, you're going to use your little arrow here to raise that to the negative 3 power. And then I end up with the answer of 2.1 approximately. So the pH is approximately 2.1 on lemon juice. All right, well that brings us to the end of this assignment here. Your assignment for tonight is number I, that's page 549. Do 4 through 15 all and 27 to 43 odd. We'll go over this a little bit more tomorrow on the next assignment, just to make sure you understand what you're doing. But you're going to be using the common log change of base formula as well. And just do the best you can, and we'll come back and take a look at it again tomorrow. All right, have a good evening.